Warm greeting to all. This session we are going to discuss Unit 4 Energy Storing Elements and Engine Components. So, the syllabus what you are going to see in this unit various types of spring, optimization of helical spring, rubber spring, flywheel considering stresses in rims and arms for engine and punching machines, connecting rod and crankshaft. So refer PSG data book 7.1002 to 7.104 for springs. Refer PSG data book 7.120 to 7.121 for flywheels. So these are the topics we are going to discuss in this unit. So these are the different springs. So the mechanical spring is an elastic member whose primary function is to deflect under load and to recover its original shape after removing the external load. So that is spring. Springs are used to absorb shocks and vibration. Example, vehicle suspension system. Store energy. Example, springs in clocks and toys. Measure force. Example, spring balance. And to apply force and control motion, example, cam and follower. So these are the specific applications of this spring. So these are the types of spring: helical spring, conical spring and torsion springs. Here this is shown helical spring different types. There is compression helical spring, tension helical spring, conical spring, volute and conical, and torsion spring, so helical torsion and spiral torsion spring, and leaf spring or laminated spring, and disc or Bellivelli spring. So these are the different types of springs available, and the advantages of helical spring. So these are easy to manufacture, these are available in wide range, these are reliable, these have constant spring rate, their performance can be predicted more accurately, their characteristics can be varied by changing dimensions. So materials for helical spring. So the helical springs are either cold formed or hot formed depending upon the size of the wire. So the less than 10 meter diameter, 10 mm diameter are usually wound cold, whereas large size wires are wound hot. And terminologies of helical spring. So the different terminologies are there in an helical spring. So one is solid length. So the solid length is, it is a compressed length of the spring, that is Ls, which is equal to N dash into D. So N dash is total number of coils. So how many coils are there, and D is diameter of the wire. So that is diameter of the wire of the spring. And free length. So free length is that is solid length plus maximum compression plus clearance between adjacent coils. So that is solid length, we know already, that is N dash D, and the maximum compression is del max, that is deflection, maximum deflection plus clearance between the adjacent coils is 0.15 del max. So the otherwise the free length will be called it as LF, which is equal to N dash D plus del max plus N dash minus 1 into 1 mm. So this is equation for find out the free length. And the spring index, is capital C equal to capital D divided by small d. Capital D is mean diameter of the coil, so the overall diameter of the coil, and D, small d, which is called diameter of the wire, so that is diameter of the wire. Spring rate K equal to W by del, that is W is load, del is deflection of the spring. Then pitch is pitch of the coil, P equal to free length divided by N dash minus 1, or else we call it as pitch of the coil, P equal to LF minus LS divided by N dash whole plus D. That is LF is free length of the spring, LS is solid length of the spring, N dash is total number of coils, and D is diameter of the wire. So these are the terminologies of helical spring. And end connections for compression helical spring. So the different ends are there, that is plain end and ground end and square end and squared and gound. So based on the application, the ends of the spring will vary. So ground, so this data is available in the PhD data book, that is ground end, total number of turns, solid length, what is free length. So plane end, so equations are given, square end, the equations are, so during the problems solving, so this table is very much used to find out the solid length and free length of the different ends of the spring. And this is end connections of tension helical spring. So different tension helical springs are there, so end connections for tension helical spring, and this is for compression spring for carrying tensile load. A spring having loops on both ends, the total number of active turns n dash, which is equal to n plus 1. So this is to find out the active number of turns of this spring. So this is the basic introduction about springs. The next session will discuss about how to solve the problem in springs. So that we'll discuss in the next class. Thank you.